Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. So today I would like to do some recap on regarding the final exam. Okay, so let's look at the last semester final exam question set. So the first one, don't forget to look at and read through the instruction. So as mentioned in last semester, you have two parts, which are the part A and part B. So you need to answer all questions in part A. Okay, so all questions in part A consists of 3 questions, question 1, question 2, and also question 3. Okay, so you need to answer all questions. And in part B, you have to answer only one question, either question 4 or 5. Or question 5 only. Or you can answer both if you have ample time, but only one question with higher marks will be considered. Okay, let's look at the question 1. So question 1 is from chapter 1, Introduction to Signal and System. Okay, so question 1. Okay, for question 1 is from chapter 1. Okay, so what's in there in chapter 1? So you have continuous time signal. And then you have also discrete signal in N domain. So continuous time in T domain. And lastly, you have signal system classification. Okay, these are the components of chapter 1. All right, so let's look at the final exam question as example. So this is only example. So do not just rely on this question, because your re-exam question will be different. Okay, so for example, question 1A. So again, I would like to stress out for you to write down all equations, every single steps. Okay, but still in the exam, you repeat the same mistake. No steps, but then your final answer appeared. All right, so let's look at the first one. Plot. So when it is plot, so you need to sketch the signal, and don't forget to put all the details in, for example, the axis and the values in your drawing or sketching. All right, so what is the 3 RAM 2T plus 3? Okay, question. Don't forget to write down the question number, the sub question number, and the first part. So it's 3 RAM of 2T plus 3. Okay, so how to deal with this? So if you don't know how the RAM signal looks like, okay, supposedly RAM signal, this is RAM T. Okay, so what is RAM T? So RAM T is also equivalent to T U T. Okay, so in this case, you know, if you represent this in terms of, this is called unit step function. So this one can also be represented as 3, whatever inside the bracket, U T plus 3. Okay, so how to sketch this? Okay, remember, if you have more than one components inside the bracket, so you may use method 3. So look at the component inside the bracket. You have more than one operation. You have the shifting, and then you have the scaling. Okay, sometimes you may have more than 2. You can have inversion as well. So look at the time. So anything happen inside the bracket is called time-based operation, and outside the bracket is the amplitude-based operation. So you can't separate this into two components. You have 3 2t plus 3 multiply with u 2t plus 3. And again, you still have to deal with the time-based operation. So when you have more than one operations inside the bracket, so you need, I recommend you to use method 3, okay? Because if you use method 1 or method 2, so you may miss some of the steps, all right? So let's deal with the first component. How UT signal looks like. So UT. So this is UT. Okay, so what happened? How to know how to sketch the 2t plus 3? So from here, you can use method 3. So state in your answer sheet, method 3. So whatever inside the bracket will be represented by tau. Tau equal to whatever inside the bracket is 2t plus 3. So now, what is t? So your t equal to tau minus 3 divided by 2. Okay, so once you have this equation, now you need to determine the new t. This is t new. So from the tau values, what is the tau values? Tau values is from the graph. So this is the original signal. Remember the first step in method 3, you need to change the axis to tau. So now this signal becomes u tau, and this is tau. So you need to identify what is t new. Okay, so let's use different page. So in this case, you have changed the axis into tau, u tau. This is 1 by default. And you have to sketch for just now 2t plus 3. Okay, tau equal to 2t plus 3, and then t equal to tau minus 3 divided by 2. Okay, look at the values. What you have, the tau values you have in the graph, right? So the first one, what happened when tau equal to 1? When tau equal to 0, so your t equal to 0 minus 3 divided by 2. It's negative 3 over 2. So you can try different values. For example, if tau equal to one negative value, negative 1, so t equal to, replace the tau values, negative 1 minus 3 divided by 2. Negative 4 divided by 2 is negative 2. So try another one positive values. Tau equal to 1. So t equal to 1 minus 3 divided by 2 is negative 2 divided by 2 is negative 1. Okay, so now put the t new values, t new. Okay, we call this t new. Okay, all these are the t new values when tau, this tau equal to 0, so it is equal to negative 3 over 2. Tau equal to 1, it is negative 1. And tau equal to negative values, it is negative 2. Okay, and then sketch the same signal on the same on the t new axis. Okay, so in this case, you have the signal looks like this. Okay, right, this is u2t plus 3. Okay, but the overall equation is 3 to t. Okay, the RAM. So, but you need to identify what is 3 2t plus 3 u 2t plus 3. So you already sketched the second component. Now you need to identify what is this, right? So this is straight line equation. So it's 60 plus 9. Okay, u to t plus 3. So how this signal looks like? Okay, so very easy. Replace when t equal to what? T equal to 0. So this the amplitude will be 9. When t equal to negative 3 plus 2, negative 3 plus 2, so 6, negative 3 plus 2, 3, 9 equal to 0. Okay, so this is the magnitude. Okay, remember outside the bracket, so outside this bracket, all amplitude-based operation. So it will only affect the amplitude, nothing to do with the t. All right, so now you can plot this. So for this equation, how the signal looks like? When t equal to 0, the magnitude is 9. When t equal to negative 3 over 2 is 0. It's supposed to be on the left-hand side. Okay, it's 9. And also here is 0. Okay, so now you already have the first component. This is the first component. And this is the second component. Then you just need to multiply them up. Right, so you have this signal multiply with this. Negative 3 over 2. So here is t equal to 0. Okay, so the signal magnitude is 1, negative 3 over 2, negative 1 onwards. So what happened? When you multiply a signal with the one having a constant 1 amplitude, so you get the same magnitude from negative 3 over 2 until infinity. So the result of here is okay, less than minus 3 over 2 is 0. So everything will be 0. Oh my God. Let me... Negative 3 over 2 and 0. So when t is less than minus 3, it will be 0. When t is larger until this one, it will be the same amplitude, crossing at 9. And then onwards, multiply with 1, so you get the same signal again and again, up to infinity. Okay, so this is your output. Okay, so I would recommend you to write down everything in sequence, okay? Because I have very limited space here, so I need to jump here and there. So it'd be good if you have everything write down continuously, all right? Okay, let's go back to the question. All right, same goes to the second one. When you have the what's the arrow? Go. Oops. Okay, look at the second component. This is very important as well because rectangular will be used in chapter 3 and 4 as well, right? So how to draw rectangular signal? So 6 rectangular 4t plus 2. 4t plus 2. So the basic rectangular signal, please recap. So this is rectangular signal. The magnitude is A from negative tau over 2 to tau over 2. So the equation will be A rectangular T over tau. So what is tau? Tau is the width of the rectangular. Okay, so if you have this amplitude is 1, negative 1 over 2 to 1 over 2. So this is the magnitude is 1, rectangular T is the axis, okay, divided by tau. So in this case, the tau is 1. So this is equal to rectangular T. Okay, so what happens when you have this equation? Okay, so again, you have, look at the time-based operation. You have more than one operation in here. So use method 3. Okay, so method 3. So what is your tau? So your tau equal to 4t plus 2. So your t equal to tau minus 2 divided by 4. So what's the value you need to replace? Okay, in this case, you have your rectangular. Oops. Okay, this is the original signal. The first step is to change the t-axis into tau. So it becomes tau. The magnitude remains the same, negative 1 over 2 and 1 over 2. So next, you need to consider what is the tau values. So in this case, you know that your tau equal to negative 1 over 2. So your t new equal to negative 5 over 8. Right, when your tau equal to 0, so your t new equal to negative 1 over 2. And when your tau equal to 1 over 2, your t new equal to negative 3 over 8. So now write down the t new values underneath the tau axis, okay? This is t new. So when it is negative 1 over 2, negative 1 over 2, so it becomes negative 5 over 8. When it is 0, so it becomes negative 1 over 2. So when it is 1 over 2, it becomes negative 3 over 8. Next, you just copy the same shape. Okay. Okay, this is for one rectangular. So this is for one rectangular for t plus 2. So, but the question you have 6. So multiply the magnitude is 6. So you have the magnitude is 6, negative 5 over 8, and then negative 3 over 8. Don't forget to label the axis as well. So this is the equation. Okay, 6 rectangular for t plus 2, and this is t. Okay, I think quite straightforward. If you write down every single thing in your answer script, I believe you can answer and you can score full mark. Okay, if you just stare at the question, look at the graph, look at the equation, and you don't write anything, you'll stuck. Okay, so let's move on to the next question. Okay, this is very easy. I suppose this is the first thing that we have discussed earlier in chapter 1, how to write down equation from the given signal. Okay, all right, so if you have this signal, what you need to do, so the first thing is to determine the component by parts. Okay, so start from the left to right. So look at how many lines or gradient signal crossing at one point. So we can start with the outer part. It's t when t equal to -2. So how many lines, how many vertical lines or slope crossing? So in this case, only one lines. So we can say one slope. So write down the equation. So the lines pointing down from this point, so it's negative. And don't forget, this should be the gradient y over x. So in this case, y is 1 divided by 1. So 1. And then the gradient. Okay, and then the t values. Right, so crossing at 2. Okay, so it's t minus, this is basic time operation, t minus -2 u t minus -2. So you already have the equation for the first loop, negative t plus 2 u t plus 2. Okay, and then move on to the next t equal to -1. So how many lines, how many slopes? So you have one slope pointing up and another one vertical line pointing up as well. So one vertical line. So please write down all equations. Okay, so next is t equal to 1 and then t equal to 2. Okay, lastly, right, you sum them up. So you get your xt equation. Okay, move on to sketch yt given new equation. Okay, so yt in this case is the derivative equation of xt. So this is your xt. So what happened when you differentiate the equation? All right, so as usual, when you have a slope, it will become a constant in after differentiation. So let me draw it down here. So it will become, so from -1 to -2, when you differentiate the slope, y equal to mx plus c, so you get a constant. So in this case, the gradient is 1, so it's -1. Okay, and then when you have a vertical line, so the magnitude is 1, 2, so it's going up. Okay, it's going up by 2. And then that's just constant, so it'll be 0 along the way until t equal to 1. So 1, you have one vertical line, the magnitude is 1, so it's going up by 1. And then lastly, you have vertical line pointing down, so by 2, so at 2, it's pointing down by 2. So this is your yt. Okay. So how to show, because it's 3 marks, how to show the steps. You can say the first component. For example, this is the first component. Oops. Oh, it changed everything. All right, it's okay. So this is the first component. So in here you say what is the first component equation? For example, y1 equal to mx plus c. So determine what is m and what is c, right? So, and then you can differentiate that dy1 over dx equal to, in this case, constant -1, all right? And then you can say the second component is the vertical line. So this the second component. So dy2 over dx. What is your y2? D of the constant, the magnitude is 2 over dx. You get del 2 del t. You get the pulses. Okay. And so on. All right. So this may represent your steps to get full 3 marks. Okay. Same goes to the third one. So now sketch a new signal ZT in which you need to use your signal into YT. So this signal will be used in here. So the signal will be multiplied with this another unit step function. So same steps as the earlier one. So again, you have more than one operation in here. Okay, you have negative, so it's inversion. And then you have shifting. So use method 3 to sketch this. Right? And don't forget you have amplitude-based operation as well. And it is inversion of the amplitude. After you solve the time-based operation, don't forget to invert the signal in amplitude. Lastly, you need to multiply this signal with yt. Okay, then you will get 3 marks for this part. And let's move on to the second part, the part C in question 1. Right, so continuous time signal, analog to digital converter, meaning that the xt becomes xn in this case, xt being converted into xn by using an ADC. So okay, please read through the statement given to you. Okay, and please jot down every single information that you have in terms of equation, values, and so on. Okay, for example, in here you have the sampling frequency of 200 Hertz. So what's the purpose of this? All right, so look at the graph given to you. This is xt, the xt being injected into the ADC, and the output is the discrete signal xn. Right, so remember, if you have discrete signal, it looks something like this. But how to know the separation distance between n equal to 1? So this is n equal to 1, n equal to 2, and so on. So how to know the separation distance? Right, so basically the separation distance is determined by t, the duration, the sampling duration. So how to get the sampling duration? From the sampling frequency, right? So fs equal to 1 over t. In this case, the sampling frequency we use as gs. So what is your fs? Is 200 Hertz. So what is your ts in this case? Ts equal to 1 over fs, in which it is equal to 5 milliseconds, right? So from here, so the first question asks you to sketch the output of ADC, xn. Okay, so in this case, you know that it should be something like this, but how to map this discrete signal into this, right? So the discrete signal being separated by 5 milliseconds, right? Look at this unit, it's millisecond. So every 5 milliseconds, there will be a discrete signal, a discrete function. Okay, so here is 5 milliseconds. Okay, you have another one. You have another, and so on. Okay, but the signal, the discrete signal varies from -4 to 4. Right, same goes to the negative side. Okay, also stated xt equal to 0 equal to x equal to n equal to 0. Okay, so in this case, when this is t equal to 0, so it's equal to n equal to 0 at this point. So it starts at the same point, right? So the first pulse will be placed at 5 milliseconds. All right, so this is 5 milliseconds. So this is the first pulse. So it will follow the same shape or magnitude of your analog signal. So this when n equal to 1, right? This is when n equal to 2, right? Same goes to the negative. This is when n equal to -1. So magnitude be this, right? N equal to -2, n equal to -3, and then n equal to -4. Okay, so the first step is to calculate the separation. Next is to map the discrete signal to the amplitude of your analog signal. And lastly, write down or sketch your answer. So these are the steps taken, okay? 0, and then you have the magnitude is 1, and then you have 0, when n equal to 1, 2, at 3 is negative, and then at 4 is 0 again. Okay, this is 3. It's negative 1. Okay, same goes to the left-hand side. Okay, don't forget to label your axis. So this is your xn, and this is your n. Okay. Next, determine the system output Zn. So where is Zn? Zn is here, and sketch the signal. So from here, you cannot jump straight away to the endpoint. You need to work through the block diagram until you get the Zn, right? So what you need to do here, first, you determine what is your Xn. So Xn is from Xt, so you already get the signal. And then what happened here? So the same signal being fed into this summation. So here is also Xn. And also the same signal being fed into the delay. Okay, a system that has delay by 3 units. So what happened to Xn? Delay meaning that the signal, the Xn, is delayed by 3. Okay, common mistake by student. Delay should be negative in here. Okay, delay by 3 units, meaning that you have X and delay 3 units, positive 3 units. So it becomes X n minus 3. Okay, so look at the symbol as well. You have negative there, right? So you get the signal here. Then the signal at this point, we can call it maybe Yn, will be multiplied by n. So Zn here equal to n Yn. Okay, all right. So the question asks you to sketch the signal Zn. Okay, so you already have Xn from 1, and then delay by 3 units. So you need to plot your Xn minus 3. So here you need to plot your Xn minus 3 signal. And then plot your Yn. So how to plot Yn? So Yn equal to Xn from 1. Okay, please sketch it again. Oops. Okay, this is your Xn. And then Xn minus 3. So the signal being delayed by 3, meaning that being shifted to the negative, positive 3, to the right by 3. So here is negative 4, negative 3. So all signal will be shifted to the right by 3. So at this point, you have something like this. Is it negative? Okay, please check this again, okay? Negative 4 become negative 1. Okay, negative 3 is 0, 1, and then here is negative 1, 2. Here is 1 become 4. Please check my sketch here. Is this correct? I hope it is. Okay, 4, 5, 6, for example. Okay, so just catch the signal being shifted, and don't forget that here Yn is equal to Xn plus negative of Xn minus 3. Okay, so meaning that Xn should be minus Xn minus 3. So this is Xn minus 3. Okay, so sketch what is your Yn. Okay, lastly, this Yn will be multiplied with n. Okay, so in this case, your Yn should be multiplied with its current n. Okay, so you should, then your final answer is in Zn. Okay, sketch, right? Okay, lastly, system. Okay, determine whether the system in dotted box. What is dotted box? Okay, dotted box from here to here, meaning that the output of the dotted box, yn, in this case, you need to determine whether yn is causal, linear, or time invariant. Okay, the question didn't ask for the definitions. You need to prove, state your argument, and justify your answer. So in this case, your yn equal to xn plus negative xn minus 3. Okay, this is for 3. Don't forget to write the question number. So yn equal to xn minus xn minus 3. So how to determine whether it is causal or not? So first, causal. Okay. What's the basic definition of causal? No future. So how to prove that this equation has no future? Okay, so in here, so you need to test with n equal to 0, n equal to -1, and 1, n equal to 1. So let's say n equal to 0. So y0 equal to x0 from this equation, yeah? Oops. x0 minus x0 minus 3. So x0 minus x3, okay, minus 3. Okay, the current state is 0. Do you have any future state? So you have 0, same state. Minus 3 is previous state, so no future. So it's causal. So test with n equal to 1 and n equal to -1. Look at if there exists any future values. For example, if n equal to 1, then if you notice in here, for example, n equal to 2, now it's higher than the current state. So in this case, it will be that's future. Okay, you have future. So once you have future, then the equation or the system is non-causal. Okay, this is just example. Okay, so you need to test these 3 n values with your equation. Okay, if you found there's no future values, so the equation is causal system. Okay, all right, so the answer for this one is causal, linear, and time invariant. So please refer to my lecture notes on system classification, how to prove whether the system is causal or non-causal. Linearity, time invariant, and the other one is what else? Memory or memoryless. Okay, so please refer to my lecture notes, my videos, and so on. All right. So I think with that, I end discussion on chapter 1. So please prepare. I believe you can score full marks if you jot down every single steps. Okay? Even if you want to write y equal to 1 plus 1 equal to 2, doesn't matter. Okay? Just write and calculate everything on the same answer script. Okay, because every single step will be counted. Even you can get half marks, okay, out of the equation. So please use your paper, your answer script wisely, okay, because every single step count. All right. With that, I end discussion for question 1 related to chapter 1. So inshallah, I'll try to prepare a recap for other questions as well. Thank you.